So let's discuss today's session, power. So how we define power, the rate at which work is done, or the other way of saying it is work done per unit time. So in terms of an equation, it would be stated as power equal to W by T, where W stands for work done and T is the time in which that work is done. It also represents, you can see how fast or how slow the work is done. So in simple words, I can say it determines the ability of an individual to do work or determines the ability of a machine to do a work. Okay. So the rate at which the work is done is being represented by power. Let's proceed further. What should be the unit for power then? The SI unit for power would be, for work it is joule, for time it is second. So obviously joule per second, which is also termed as watt. Okay, so power, the unit for power is watt, represented by W in the name of James Watt, basically. Let's move ahead then. How do we define 1 watt? So we say the power is 1 watt if okay, we say the power is 1 watt if 1 joule of work is done in 1 second. So if you can say it is the power of individual to do 1 joule of work in 1 second, friends. This is how we place 1 watt. Okay, we define 1 watt, friends. So let's proceed further then. So in terms of energy, if we want to define power, how we define power? Okay. So basically, when we talk about work done is the amount of energy consumed, or you also put energy as capacity to do work. Or if you talk about work done, other way around, you will say amount of energy consumed. So what is power then? So power is the energy consumed per unit time. So that's how you define power as the unit for power as joule per second. You can either talk in terms of power with respect to work done or with respect to energy consumed. So in simple words, power in terms of energy, you can say it's the rate at which the energy is consumed, or in terms of work done is you can say it is the rate at which work is done. Okay, let's talk about the units, relation between the units, kilowatt and megawatt with respect to watt. So here you should note down 1 kilowatt would be equal to 1000 watt or 10 raised to 3 watt. 1 megawatt will be 10 raised to 6 watt. So this is the correlation between watt, kilowatt and megawatt. Okay, what can be the other units of power? So the commercial unit basically is horsepower. So 1 horsepower is termed as 746 watt. Okay, this is something which is to be noted. Yeah, friends. So in this problem, you can see they say a constant force of 2.5 Newton accelerates a stationary particle of mass 15 gram through a displacement of 2.5 meter. So here you can see initially the mass was at rest, initial velocity is 0. You apply a force of 2.5 Newton, and it displaces the body by 2.5 meter. So in this process, you can see it's a it's a case where you are supposed to find the work done and the average power delivered to this body so that it moves through 2.5 meter. Now, under the given circumstances, friends, here you can see first thing what you can do is you will use the concept of work done. How we work out work done? Force into displacement, dot product of force and displacement. We know the value of force, we know the value of displacement. So simple, they are in the same line, therefore theta is 0, cos 0 is 1. Now here you can see the angle between force vector and the displacement vector is 0. So cos 0 is 1. So Fs cos theta, so cos 0 is 1. So it will be simply 2.5 into 2.5, that is 6.25 joules. So first step is to find out work done. So work done, we got it as 6.25 joules. Second thing is the average power delivered. Now for finding out average power delivered, first we need to know the acceleration of this object. How we work out the acceleration? Force divided by mass, because we will be using Newton's second law over here. Force is equal to mass into acceleration. So corresponding acceleration will be force divided by mass. So force is 2.5 and mass after converting it into kg, it is 0.015. So when you divide it, you get this as 500 by 3 meter per second square. That's why I have mentioned acceleration as 500 by 3 meter per second square over here. Now using kinematical equation of motion, second equation of motion, s is equal to ut plus half at square. Ut becomes 0. Why? Because u is 0. So simply I can get the value of t as t square as 2s divided by a. Now I know the displacement, I know the acceleration. Acceleration I have estimated as 500 by 3. I will just substitute it over here. So when I do that, I get the value of time period in which this entire thing happens equal to root 3 by 10 seconds. Now, once I know time, once I know work, I can find out the average power as work divided by time. When I divide it, I work out the value for average power delivered. So please make a note of this. So then in that case, you can see the average power delivered would be 36.08 watt. Please make a note of it.